Nothing up my sleeves. Ladies and gentlemen, welcome to Turn Right Machine Works, and my name is Keith. And today we're finally getting on the Wright Roller Kits. We're actually going to be manufacturing 3 sets. I want a new set for myself in here, plus I'm going to need another set to mount up for follower rollers on my little blue lathe. When I get that set up, I want to be able to run round stock out each end of my lathe, just like I do on the clothing lathe over here with the set of rollers I have there. And I will take in my original set, this set here, I made these back in 92, 93, and I've been using them constantly since then. I've replaced the bearings a couple times, but other than that, that is the original set. And I have another set that I actually use on my clothing lathe, and I'll convert these to mount on a post just like I did there. And the new set will be my new bench set. So continuing on here, when you order a Wright Roller set, it arrives to your place in a box like this, and that's because I want extra protection on getting the Wright Roller Kit to you. It is a mass of steel going in a smaller box, and it happens to fit in one of these priorities. Inside that box you'll get this box, which actually has all the components to machine for your kit, and you'll also get a get her done sticker, and you get the drawings that I insert into the kit so that you have a paper copy. This is also available PDF files on my web page as well, just in case you get oil on them, dirt on them, ripped, the dog ate them, whatever. Alright, so let's go ahead and get set up here, and I'm gonna open up this box here, and then we're going to talk a little bit about the drawing, because there's a mistake in the drawing, and then there's some information that's left out from the drawing, and I'll tell you why. Okay, let's set this over to the side for a minute, and let's go ahead and put our rag up here. Oh. I always continuously ask Vanessa, is this a rag, is this a rag, is this a rag? So this one here is just new to the shop out here, and now she folds it, puts it on the dining room table on my side, and she writes rag right on them. So actually, if I'm walking around and this is written on my back and I don't know it, would somebody let me know? All right, let's open up the kit, and we'll bring out all the components, show you. Your kit arrives just like you saw me pack it up. Okay, and I just go ahead and we'll set these 4 pieces over here. There's one of the small tubes in there. Now this tube is actually what's on the drawing, and the length on the drawing is longer than it needs to be. So this needs to be machined to suit its location, and that's the only thing that you need to know about this part. And you machine this fit, and when we get into machining this, I'll explain and I'll show you how I fit this in and why it's important this should be in there. Alright, the 2 bolts, I'm just kind of like setting them off to the side until I get rid of the paper here. Okay, you get 3 bearings, you get your other tube, and you get one of the axles in that one, and you get your pivot post and your other 2 axles in that one. Alright, your end blocks that hold the axles supported in the tube. Your 4 keepers, and your 2 base plates. And I stamp these, or my little helper stamps these, and I put the stamp and the year that the kit is made and packed up right on the side there. Alright, so let me lay these out. 2 base plates, 2 tubes, 4 end plates, 4 end blocks, 4 keepers. You should have 4 short axles for the bearings, and then these are the trunnion shafts here. You will get 4 bearings, you get 2 bolts, and you get 2 center space supports. Alright, and all those components right there will make a set of rollers. Okay, I've got 2 1/4 inch wide by 3/4 parallels down in here. That's no important, that's just my resting point there. I have a spring down in there that holds them from moving around so that I can load parts in and out of here. The very first thing we're going to do is we're going to go ahead and we're going to be machining our box tube sections. And the first thing I'm going to do is go ahead and face off the ends. So I have a stop set here, a resting point there, and just to start off the whole job, I want to verify that I am 0 to the back edge of my vise, and then after that, then I can start putting stuff in here, and I can come to my readout whenever I want. Or dials. If you didn't have a readout, you'd just be using your dials. And sometimes I do set the dials, but I'm not going to bother right now. And I just touch off and kicks it aside. I'm at 250, so I haven't lost my setup, and I'm just verifying that. All right, now this is box tube 2x1. Is it a true 2x1? Well, let's see. I'm getting about 10 thousandths over, and this way here I'm getting about 3 thousandths over. Alright, so if we wanted to be true and we're coming to center of here, we'd want to offset it at least 5 thousandths, half of the 10 that this is taller. Are they falling in line with each other? That's 12 over. That's 9 under. I mean, it should be 9 over, meaning it's under the other. There's 10. There's 8. So we're just going to consider, you know, if we're plus or minus 5 thousandths on this thing, you can set your own standards that you want to hold your machined set of Wright rollers to. Now, I didn't have every fancy dandy thing when I machined my very first set. I was just starting out in my little shop in the garage. And so some of these things I'm going to be just pushing on through, and I'm not going to be doing every single thing as a machine operation. I'm actually going to show you how to do a little hand shaping on the sander and some things like that. But the drawing is there so that you can carry it to the detail you want. Alright, the first thing I do, we're going to find a common length in all of these. The drawing actually has it drawn out at, let me turn the page to the drawing. Six inches. And they've drawn it out to 2 places there. So what I do is I kind of just look here, which is the shortest one. This is the shortest one out of my batch of parts that I'm doing. I'm doing 3 sets, so I got 6 of them up here. Alright, so I grab my calipers again, and this time here I just want to go ahead and I want to read off the length here, and I'm 6 inches 85, 6 inches 85, and I go through and measure each one of these, but I believe by just looking at that one there, it looked like it was the shortest. Alright, so it looks like we could clean up to 6 inches. Now, some of these I might have been saw cut, or it might be off at an angle, and to get it clean up, you might be slightly under 6 inches. It's not important that it be exactly 6 inches. It is important to go ahead and have both of them equal to each other if you're going to run them through a mill and you're going to create the same cutouts, holes, axles, radiuses, threads, anything that pertains to the part to be equal with each other. Alright, I think I put it there. Alright, now we'll go ahead and we'll put it in here. Now, I went around looking for an end mill that I'm going to use for doing all the facing on these parts, but also facing on the end plates and things like that. I grabbed one of my Niagara cutters, and this wasn't in the set that I just received from Dennis, but it is a Niagara cutter and it is brand new. I received this one sometime during last year's giveaway, and it was included in the tooling that was allotted for me, and that's where it's from. But this is a brand spanking new Niagara cutter, and I will promote Niagara on the video here. And anyhow, I wanted to make that as a note there. I'm doing the video not necessarily just because the Niagara cutter. I just happened to pick out a Niagara cutter which I already had in my own possession here in my shop. They are a nice cutter and I do use them. One thing that's handy about using a 3/4 and a 3/4 collet on my drill chuck is I can just change out from drill chuck to end mill in a flash. Alright, let's bring this up so we're not going to be hanging our spindle down so much. Okay, now we're gonna go ahead and lay these down. We don't need them up in the way anymore. And center up our cutter here. You know, I might run the top of a cutter. I kind of like shift it up and down depending, because we're going to be making multiple passes, so we got at least 12 passes minimum if we're doing them in one pass each to do the cleanup. But we're going to pick a depth, and we're going to go across all of them. And then after that, then we're going to put one in there. We're going to set it for the length we're going to have, and then we'll go through all the rest of them. And we'll go ahead and we'll slow that down just a little bit. I'm not gonna. One thing that's nice about the turbo end mills or the roughing mills is that they cut with ease. There's hardly any. They're real nice to do hand maneuvers where you're coming in and you're freehanding your cut. It really is nice. Alright, so I'm just touching this, and we'll just zero out that axis there, the x-axis, and we're just giving it like 15 or 16 here. Alright, now we're just going to feed it in. Okay, we're going to go through and we're going to face off all 6 of these. Okay, I'm looking back there. I've seen that it hit everywhere, so I'm just going to back out just a couple thousandths and I'm going to come on back. I preset while that was cutting, I set that point in the axis at 0, so I come back to 0. And the main thing is I just want to make sure that this is flat. The lines that a turbo end mill, and that doesn't bother me. Okay, and I'll sand a little bit, kiss it with a sander or whatever. But that surface just needs to be flat and true, flat and square this way, and flat and square this way. Okay, we went in the other room and we put this end against the sander, broke that little sharp edge all the way around here. So this is deburred, and we're ready to go ahead and put them in the other direction and get the finish on the other side. So we're going to go ahead and take a light skim. We're going to measure the overall length, and then we're going to adjust that with the first one, and we're just going to feed the rest of them all the way through. we touched a little bit. We're taking, set our 0 there. We don't really have to cut all the way across, but we're going to see if it does clean up. Okay, let's see how she did. Our saw cuts are pretty uniform. You know, 5/1000ths off of that, and it cleaned it all up. All right, let's go ahead and let's take a quick measurement here of what we actually have on a part length. Okay, I got 6 inches 48. So we'll take our, from our 0 point, we're going to punch in 48/1000ths. And we'll re-zero that. Here we go. Okay. All right, let's see what our overall length is now. And we're at 5 inches 999. So we're just about 1/1000th under as far as what my Mitutoyo dials are reading. And we're going to leave it right there. All we need is all the same length, and 1 or 2 thousandths either way is not going to make beans here. All right. Here we go, and we're going to go ahead and we'll go through this collection now with this process. And we'll catch you up when we change to the next operation here. Well, that didn't take long, did it? I deburred the other section there. Alright, and while we were just taking a couple seconds there, we went ahead and vacuumed up our mess here. We went ahead and moved our stop back because we want to get these things down into the vise here. And we put our drill chuck up here with our edge finder so that we can go ahead and zero in on this part. But before I put it in the vise here, I want to talk a little bit about the welded seam on the inside of the box tube. If I was at the metal house and I was picking out a piece of box tube and physically staring at it to make my project, I would concern myself a little bit with where that seam is. Ideally, I would like it to be down on the bottom edge, down in the root down here with the part here, and away from any of my machine work, with the exception of sliding the blocks in, and I'd just be able to dress up the little bottom there. So anyway, with that in mind, how do you set this up to do the side holes when we know that there's a seam right here? Well, sometimes if you have it on the bottom and you come down through there and you're hitting your drill point off of there, it's wanting to shoot it off and give you a funky little start to your opposite side hole. So I tend to like have it up, and that way it goes through, and as you pierce through, you're leaving that spot, and then you're starting with a nice fresh surface on the bottom to go through the rest of the part. All right, so that's why I'm locating them in like this, and I think every one of these has got a side seam. They all came out of this, basically the same part, or same piece of 22 footer, 23 footer, something like that, that the box tube comes in full length. Alright, so now we just need to touch off, and let's see what we actually have on this piece here. They did vary a little bit, and this one here is 6 inches 1/1000th, maybe 2, but we're just going to go ahead and we're going to touch off, and then we're going to come over to center of this, and then we're going to set 0 on there. So then we'll have a 0 here on the back edge of the vise, and 0 as far as center line from our part, and then we'll be able to machine the rest of it. And then after we do that, I'm going to make one more setup, because some of the milling or drilling that I'm going to do here, I need to have this jaw out of the way, and I'm not able to get there. So I'm going to add in a couple extra blocks so that I'm holding this up in the right position. Alright, we're just coming over to our edge of our part here. And actually, there's pluses and minuses, and actually I like to spin a little faster on my not quite top end. That'll be fine. I just think it reads a little better. I do it a couple times just to make sure. And we're kicking out in the same spot. And it looks good to me. Alright, crank in half of our diameter there, 250. And reset 0. Alright, and let's come over half of our part, which will be 3 inches right on the money. And there we go. And re-0. Okay, our first hole we're going to be putting in each one of these pieces is going to be the 1/4 inch hole right in the center that holds the plate right here, and that 1/4 inch hole goes through both halves, and that is 1 inch up from the bottom and center of the part, and that's it right there. And you can see we're going to be coming down almost right on that weld seam there. Alright, let's see how this bit, this is given to me. I don't know what the actual coating is on it. We'll get it in the right direction there. And we're about 660 RPMs here. No coolant. Pretty effortlessly was able to put that hole in there, and a bolt's going through there, so it's not a high-tech hole, but we do want it to be in the center. Didn't really push too much of a chip there or on the bottom, so it's kind of a clean drilling drill. It was sharp, it cut it, it didn't push it. Alright, I kind of like that. Alright, now I had that in here like this. Of course, it would line up either way if I was exactly true. But what I want to do is, I want to go ahead and I'm going to mark the spot I have against the rest. When you get to putting in a lot of parts, I have a habit myself of maybe grabbing the part and throwing it in there a little bit different. Even when we're doing the facing, my very last one, I put it in, I almost faced the same surface I already faced, and it would have left a virgin saw cut on the other side, and the part would have had to been set up for the next section of parts or whatever, or scrapped out, or you know, you never know what the problem might run into. All right, so we marked it, so we know that we're going to be, we'll set it up here like that. And we're going to go ahead, and I like the seam where it's at, so I'm going to put that seam up at that side. We're going to mark it there. I can tell which way it is. Alright, there we go. At least that way I know that I'm putting them all in the same way, and each time I locate my part, I'm going to be looking at where do I have it in there in relationship to matching with all the rest of them. All right, we're going to drill this 1/4 inch holes through the rest of these, and then we'll bring you back in. Okay, we're ready to catch up with our roadmap here and see our next plan here. I'm going to leave this 1/4 inch drill in here, and I'm going to go ahead and drill the pilot for the 2 bearing axles. And that's going to be out from the center 1 inch and 63 thousandths, and from the bottom on up it's going to be 1 inch and 1/4. So we'll just come up the 1 inch and 1/4. So there's 250 right there, and now each way it's going to be 1 inch and 63 thousandths. And now I have a choice to go ahead and drill this one on all of these, meaning taking in and out the part for each one of these, and then move over there and then drill the other, or I can go back and forth. And I think I'm going to go ahead and I'm going to drill all of these on this side, and then I'm going to drill all the ones on that side, so that I'm only moving the table 1 increment and I'm taking the part in and out. It seems a little faster to me. Other people might want to go do everything. If it was automated, you wouldn't be pulling the part out at all. But you know, when you're physically doing something, is it faster to do it physically by moving the table or taking it out of the jaw and throwing the next one in there? All right, let's go the right direction. All right, and here we go.
Get my air and everything else all set and ready to go here.
One thing about taking in and out the part, you're not sitting there mentally stressed out about a number every time you're trying to land it. You know that you're solid in against the stop. And either we got all of these in the right spot or we messed them all up. Okay, now I can leave this one right in here because I'm going to go ahead and move over to the next hole, which is just 180 from the part. So it's just 1 inch and 63 over to this side. Same height. Just taking a second here. Okay, now if we take this part and then we go ahead and we put this part like that, so we got the stop over here, stop over there, and we look through and we can see straight through all the holes lined up exactly. So we're equal. We're no matter which way these go, we are equal, but we're going to still go by our mark and keep our mark in line and continue on our way here, just verifying that our holes are in the right location and we're not scrapping any parts. All right, we're going to go ahead and lower our table a little bit because our next drill is going to be this one here, and I want to be able to get it in and out. There we go. Okay, we're going to reduce our speed now. That might be comfortable. Now we're drilling this out. My finish hole is going to be a reamer. I have a reamer that's .6253. So it's just really 3/10 of an inch clearance. I used to have one right on the money, but it finally dulled up and I had to chuck it out. It upset me and I round filed it. And so I'm going to go there, but I don't mind these axles being a slip fit. I prefer a slip fit on these axles, and I'll show you when we go for assembling. I'll show you why I prefer a slight slip fit on it, and it doesn't affect the accuracy of the performance out of the roller set. Okay, every once in a while you get a drill bit that wanders around and wants to give a hexagonal or an octagon type of cut, and I'm not real happy with that action there, so let's take a look at this. Does look pretty good. It's a little bit, I probably, somebody, okay, this is my drill. I'm going to go bring a crisp edge to this. I put a slight flat there so it wouldn't grab on some materials. But on this here, I want it to shit and get, so, alright, let me go sharpen it up. Alright, let's go ahead and throw this in here. I dressed it up a little bit. And let's see if we're making any difference here. Alright, the main importance is I want to make sure that we're tight on the hole so that we got room to ream. I just don't want to be creating a hole that's oversized, and we're doing good. This is actually drilling about 612, 615. So we got 10-15 thousandths, and that's okay to ream from there. All right, put this back in here. We're going to go down and we're going to do the one at the other side. Okay, I noticed on this one here, I was still getting a little bit of the washing. It's still a good hole. I'm still tight enough to clean it up with a reamer and have a really nice tight fit. But I'm going to also show you, sometimes when you got these old mills, I mean, this Bridgeport here has seen its better days. Okay, there's nothing to brag on this except for, well, it's got auto feeds. It's got a readout. Okay, right. Regardless, what I'm trying to get to is, if you're having problems reaching out and not really getting the right cut finish and things like that, reduce your hangout, just like on the lathe and stuff like that. So what I did is I took the drill bit and put it right into a 1/2 inch collet, brought my table up, and now we're not going to be extending as far. All right, so same hole. Make sure you lock down your tables. A lot better. It's not walking around. It's giving a more consistent hole. Really nice. Nice clean. Okay, now that's a good 610. .610, 611. All right, so we're still holding a good diameter, but that hole definitely looks a lot cleaner. That hole looks a lot cleaner than that hole there, and that was from walking around. And now I'm able to grab a sharp, crisp edge onto it. All right, back to drilling. Okay, the last one going in here for drilling. and then we'll change it out for the reamer. And this has been really constant. Really nice looking holes with this. Now if you didn't have a reamer, you could bring it out to a drill just underneath, the 64th or 32nd. You can take your choice from there. And then coming in and probably turning real slow with a 5/8 drill would give you a clean enough hole for the pin in. You would just take some piece of box tubing and simulate the situation you have. All right, I get that out. And take out the collet. This is the reamer we're going to use.